Scott, this is the EA12V. I know the EA range is very popular in the UK. Why is it so appealing and why is it so popular?
The long history with Mitsubishi, and I myself working with the die sink, and what I found is over the years, what you can do, first of all, with this controller, for special applications, difficult, let me say, what are not the normal kind of applications where you might be just sparking straight down in the Z-axis. The control has always really lent itself to those kind of options. So for the standard sort of job shop, for number one, because straight away we're thinking about mold makers, die makers. But when we talk about subcontract, Formula One, splines, gears, undercuts, those kind of things, the control really starts to open itself up to that. Separate to that, one of the hardest materials to machine in die sinking is carbide, polycrystallized diamond, these kind of materials. And historically, you would have a standard machine that would be capable of sparking graphite or copper into a workpiece, normally a steel workpiece for the mold maker. But when it came to sparking these harder materials, such as the carbides and PCDs, you would need special generators. And those special generators inherently, it was just about raw power. And putting that raw power into the parent material actually would cause micro cracking and damage the material. The generator here has a higher acceleration rate, the way the impulse actually comes on, really lends itself to carbide machining. And whereas people, when they're using standard generators to spark carbide, might see with their copper tungsten electrodes 20, 30, 25% wear. Here, we're seeing as little as 15% electrode wear, which is a massive difference for the carbide sector. When we move into the polycrystallized diamond, again, a combination of the generator and the option that's available on the machine for that, again, starts to open up those more difficult markets. So it's not just about a standard mold and die shop die sinker. Anybody looking to do something a little bit out of the norm, subcontract, carbide work, polycrystallized diamond, this is what the machine for those people.
So we've talked about carbide and PCD, but how about the mold makers? So how is it going to cope with steels?
So for as long as I can remember, the technology, certainly when we talk about copper to steel technology, was always very, very strong, very, very stable, able to get very, very good surface finishes. And when I think about when I started, quite often the comments would be about corner wear when we talk about copper. Over the years, there's been a lot of development in graphite technology, adaptive waveform circuits to reduce graphite wear, and we see this quite commonly on the marketplace. So the Mitsubishi also has an adaptive waveform, and with the standard machine we have an 80V generator or a 120V generator.
What other models are available in this range?
So going up, we have the EA28. It's a much larger machine, same kind of construction, rise and fall tank, glass scales on all the axis, thermal displacement control, and the thermal displacement control stops any influence. If you have a roller shutter door, for example, putting some cold air onto one side of the machine to really give the customer the highest accuracy. Slightly smaller to that, we have the EA8V, and this machine has a granite table and a nanopulse generator. So when you're trying to get down to surface finishes as little as 0.1, 0.15 RA, very, very high precision, then we perhaps move into that machine range.
And can we add automation to any of these machines?
All of these machines are ready to take automation. So we have a standard 20-position tool changer. Let me say that's the standard for a lot of customers. But we simply can remove that tool changer and we put on either a Mitsubishi solution with the Melfa series. And the beauty about the Melfa series is really with the Melfa series we can adapt it to suit any kind of component, any kind of racking. We can modify the jaws. Or of course there's other tooling manufacturers that have standard solutions and they can all be integrated. The generator can have a right-hand side or left-hand side configuration, so it's also possible to pair two machines together with one automation system.
So we've talked about mold makers. I know we've got an example on the table here, so let's go and have a look at it.
Sure.
What have we got here, Scott?
So if we look at this particular part, this was a test that a company asked us to do, and what they were looking for using graphite electrodes was to sink an impression in solid, and not only were they looking at the electrode wear, but they were looking to see how homogeneous the surface finish is. And as we look from part to part, what we can see is the surface texture remains constant throughout, and the corner definition in the corners has been held up. That particular example was used with 3 electrodes. Next to that, we have what I would call a sort of typical sort of mold. You can see it represents a handset control set. So we've got a lot of, first of all, a lot of the wire EDM's been put in with the slides, and some of this was pre-milled. And here the idea was to bring in the electrode to not only put in the surface finish and the texture in, but you can see we have some very thin rib details, and trying to get down into that rib detail, really EDM is really the only option.
And what are these smaller parts on the end?
So the smaller parts represent, I would say, the more exotic materials. But when I say exotic, carbide being the first one, which it's becoming more and more of a standard. So here we have an example of a roping die. So it's a steel outer body with a carbide insert. And that carbide insert would be, first of all, rough EDM'd with copper tungsten electrodes, and then finished down to a surface finish around about 0.2 RA. Then it'll probably have the final polishing. Here we have a carbide indexable tip, and whilst we might spark the form in the centre, we also have customers that will spark eroding the dies and also the surface form. If you think of the chip breakers that you see on your indexable tooling, sparking those forms to very, very high tolerances. Some of the leading tooling manufacturers have our technology. Moving alongside that, this material here is what we call CBN, and we also have PCD, polycrystallized diamond. This is incredibly difficult to machine, not just because of the toughness, but the conductivity of the part. So we have a special generator, and in the disc we will place the screw holes, which would invariably be for the indexable tip, and then afterwards it would go to one of our high voltage generator wire machines to have the indexable tip wired out.
And I know this range, along with all of the range from Mitsubishi, it's available exclusively from HK Technologies.
Yeah, that's right. We're here today at Mitsubishi headquarters in Düsseldorf to show you what's behind HK. We have machines in the demo room there, but if anybody wants to come and see some of the other options, they're more than welcome, and we'd happily join them here in Düsseldorf.